Hello everyone. Welcome to the fourth tutorial session of the Probability Foundation for Electrical Engineers, and who is instructor is Professor Krishna Jagannathan sir from IIT Madras, and I am Satyavikram Pratap Singh, a PMRF research scholar at Grid Integration Laboratory, IIT Bombay. So in this tutorial session, we will solve few of the numericals that will help you to solve the fifth assignment of the this course. Okay, so the process will be such that I will be giving the few of the problems related to your concept which is required to solve that assignment, and then we will move forward to check that how that will be helping. And if you face any doubt or any help you require to solve this problem, just let me know and take few minutes to solve the problem, and after that I will give the solution of that problem. Okay, let's move forward. So this is the first problem. This is related to the infinite cost also in the series based problem. So this is the first problem. What it is saying that a fair coin is tossed infinitely many times. A is the infinitely many heads which is occurring, and the B is the only finitely many tails occurs. Okay, you have to tell me which is the options is correct. That is, a PA is equal to 1, PP is equal to 0, or PA is equal to 0, PP is equal to 1, or PA and PP both are equally defined that it should be 1, and or the both the probability is 0. Okay, take few minutes and try to solve the problem, and let me know if you face any doubt, and after a few minutes I will give the solution. Okay. Okay, let me give the solution for this. Okay. So it is being said that there are infinitely many tosses were there for the option A, means A probability A event. So it means that when you say the infinitely many times, it means that when you toss it, suppose the probability of A when you see that occurrence, basically occurrence will be such that infinitely many times means a head it comes first, then second also, third also, then dot 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 infinite times. Okay, so total occurrence will be also that such that all the probabilities would be head only. So that's why if you see the all the denominator, when you take the occurrence or the total occurrence, that is actually equal, that will be probability is equal to 1. And if you already know that infinitely many tails, and B is the only finitely many tails occur. Okay, so you already know that probability, total probability is basically probability of head plus probability of tail. Okay, So when you it is already 1, and this head occurring of the head is actually 1, so by default the probability of occurring of the tail will be equal to 1 minus 1, that is 0. Okay, so the option A will be the correct. When you see the solution also, why A is actually correct. The event A says that ki infinitely many heads occur. Each toss is independent because the occurrence of one is not depending upon the other. So that's why pH is zero point 0.5. Zero point 0.5 means ki half is occurrence of the head, zero point 0.5 occurrence of the tail. Okay. By the Borel-Cantelli lemma, it is stated that ki summation of pH is called infinite and the tosses are independent. Head occurs infinitely often, so that's why the probability is 1. Okay. And if you see the probability of B here, the event B, it is only finitely many tails. Okay, so it means that the probability of getting tail is also zero point 0.5, but it is also said that infinitely many tosses are there. So tails occur infinitely often with the probability 1. So that's why the probability of finitely many tails will be 0. Okay, so that's why the option A is actually correct. Okay, okay. So let's move forward. Try to solve this problem. Try to solve this problem. Okay, let me give the solution for this. When you read the question, what is telling that a coin being biased bias within probability is zero point 0.6, not zero point 0.5. Okay, the occurrence of the both the head or tail, it is not equal. Okay, so that's why it's a zero point 0.6, so it is called as bias. And it's twice until two consecutive hit occurs. Let n be the number of the tosses, then p is equal to n is equal to 3. Okay, it means that it is saying that ki number of occurrence is already 3, means number of occurrence is already been said that it is 3. Okay, and it is also saying two consecutive head appears. Okay, let n be the total number of tosses. When you see that ki, in three occurrences, the two consecutive head when appears, you should stop it. Okay, so it will be possibility that you can get and it's already there, it's a three occurrence are there, so it means that key two consecutive hits are occurring at the end. Okay, and initial is 10. Okay, so when the occurrence of the probability of the coin with the bias, this is tossed and the two consecutive head appears. Let me see. Okay, when you see that p is equal to p n is equal to 3, with the zero point 0.6 is being consecutive head appears, so it means that let's assume that it is the probability of occurrence of head, so head is zero point 0.6 and probability of occurrence of tail is actually zero point 0.4. Okay, so when you say the first occurrence of is tail, so it means that it's a probability is 1 by p, and head it means that p and p. Okay, p square 1 minus p is already given, that is actually equal to zero point 0.6. zero point 0.6 of a square multiplied by zero point 0.4, it means it is 0.36 multiplied by zero point 0.4. When you solve it, you will get 6 4 24 4 3 14. Okay, it's a 0.144. So option C is actually correct. So it is simply what is telling that key we need the three occurrences and stop when the exactly the third toss is at the third toss. It means that key first will be tail and the probability other two will be the head. Okay, so here the head is zero point 0.6 zero point 0.6, so here it is zero point 0.4, that is probability of the tail. So that's why p square 1 minus p. So the correct option will come out to be 0.144. Okay, option C. Uh, Here also the quick example one that ki if equal occurrence are there, so it means that ki, at third consecutive tells me ki, at the end of the two we will get the two heads, that is zero point 0.5 only. So here the 0.125. So 12.5% which chances that ki you will get the third last two tosses will be the head. But here if you see the probability is put in zero point 0.4. Okay, so that comes because it is actually a bias coin. Okay, try to solve this problem. Let me know if you have any doubt. Okay, let me give the solution for this problem. It is telling that ki when you have the independent coin tosses with the probability of head being the p, and defining the event which is no two consecutive heads ever occur, okay, then what is the probability of getting then the what which option is actually correct? Probability of e is equal to 0 if p is greater than 0, probability of e is equal to 1 by p, and probability of e is 1 upon 1 plus p is equal to 1. Okay, so it means that ki when you toss a fundamental coin tosses with the probability of hit, so it is already been given that ph is equal to p, and the event e is being said that ki no two heads ever occur consecutively. Okay, so if you are having a probability of head as p, it means that when you no consecutive two heads will be occur, it means that ki you are getting tails in the two consecutive terms. So it is being told that ki no two heads ever occur consecutively, the infinite tosses. The pH is actually given as P. So step one is that if you know two heads which occur, so whenever a head appears, it must be always be followed by at least one tail. It means like this: head, tail, kind of. Okay. So that's why the no two consecutive terms occurrence would be of head. Okay. But as soon as you get the double H, means head hit, the event fails. Okay, so it means that infinitely many tosses with the probability of 1. When you use this Boral Cantelli lemma, so it will be sub that ki probability of p should be greater than 0. Okay, so for formally, if you're saying that ki summation all the event which is occurring at the position of n and n plus 1, that is head appear at the positions. Okay, so summation of p is equal to actually summation of the p square, which is actually infinite. Okay, because occurrence of one particular event is given here, that is actually infinite when you sum it up. Okay, so by this lemma, it is being said the probability of one is infinitely many when the en occurs. So that's why the probability of e will be equal to 0 for all p greater than 0. Okay, so that's why the probability of getting e is a 0, because no independent causes join which is continuously being head. Okay, and it is also being said that here probability of en is equal to summation of p square when you add the p terms and get to the infinite, so overall summation will be infinite. Okay, why 1 minus p? Because the probability that the first toss is not head is it's not a not the infinite sequence event. Okay, so 1 upon 1 plus p, it doesn't make sense. One, this is only true when the p is equal to 0, means coin never gives head. Okay, all the events are tail kind of. Okay, so that's why it's a probability of e is equal to 0. Try to solve this problem. Here it is saying that ki x is the number of tosses, only the first toss with the bias is equal to 0.25. What is the actual the value when the you get the probability of x is greater than 5? Okay, try to solve this. Okay, let me give the solution. Here it is saying that when the x is the number of tosses, which is until the first hit with the bias is 0.25, which is occurs, p x greater than 5. Okay, so considering that p is greater than 5, x is greater than 5, let's take it p is x is less than or equal to 5. Okay, that is also true because p is x greater than 5 will be equal to 1 minus this. Okay, so if you see that pt is 1 minus p kind of x greater than 5 and this one, and then 1 minus p x less than 5, then when you see that key first head occurs. Okay, so x less than or equal to phi, it means that key let's at fifth occurrence the head will occur. Okay, so it will be 0.25, 0.25, 0.25 kind of. Okay, 1 minus 0.25. Let me again give a glimpse of that. Okay, 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 okay. Probability x, let's remove this also. Okay, probability of x greater than 5 is equal to first head occurs is simply equal to x greater than 5 simply equal to probability of getting first head when the occurrence of this, so it will be 0.75, 0.75 dot till the fifth term. Okay, it will be simply equal to 0.75 or 5. Then you see that bias coin the probability of p is equal to 0.25 and the number of until you get the first tail, first head. So first all tosses will be retail. So after just fifth you will get greater than 5 means after the fifth event you will get the first head. Okay, so the probability of getting the tail is 0.75 because all the first tosses, 5 tosses will be the tail. So it's a 0.75 to the power 5. So that's why the option A is actually correct. Okay, let's move forward, try to solve this. Okay, let me give the solution for this. It's saying that ki if air is coin is being tossed and an is the nth toss is hit, and the probability that infinitely many an occurs is okay. When you see that ki an is actually the nth toss being hit, and what is being asked that ki what is probability that infinitely many an will occur. Okay, so occurrence of a single event when you toss a one coin, that is point 0.5 basically. And if the infinite sequence occurs, okay, so it means that when you Borel Cantley lemma when you apply and sum it up from the n to infinity, it will become infinite. Okay, and the events are independent, so infinitely many events occur, so that's why the probability is being 1. Okay, and also you can intuitively see that when the occurrence of the probability is that much infinite times, so the it will be 1 only. Okay, so that's option B is actually correct. Try to solve this. So what's the problem is saying that ki in 0 to 1, when you apply the Lebesgue measure, it is defining that an is between the 0 to 1 by n, and it's open in a closed interval basically. And then it is asking the limit of SUP, that is n tends to infinity of an is okay. When you solve it, it is saying that ki, when you say that ki x is belonging to the 0 to 1 and x is belonging to the an for infinitely many n, okay. So let's considering that ki x is greater than 0, and choose that ki n is greater than 1 by x, so it will be out of the box, okay. So then 1 by n will be the less than x, so x will be belonging to the 0 to 1 by n, okay. So that's why the sufficiently large number of n, x is not an, okay. Hence x is belong to the only finitely many n, okay. But when you consider the x is equal to 0, because it is occurring into this because x is what we are considering an, that is the closed interval in between the 0 to 1 by n. But here we are considering 0, which is out of the this overall bracket, okay. So it means that it doesn't contain 0. That's why 0 is never inside of this an. So that's why the no point is of 0 1 belonging to the an. So that's why the limit will be 5, null set, okay. Try to solve this problem. That simply is that ki an is in the closed interval, that is 1 by n to 1, okay. You are asking limit in limits n tends to infinity, that is this limit n tends to infinity an, okay. Try to solve this. Okay, let me give the solution for this. So in this, what is asking the limit infinite, that is an, and x is belonging to an but infinitely many times, okay. first few sets like a1 is 0 to 1 or a2 is equal to 1 1, because it's already being defined. An is equal to 1 by n and 1, and it's a open interval. It means that the boundary values will also be included in this set. Okay, so it is, the possibilities are there that 0 to 1, 0 1 1 1 1 2 2 1, or for n greater than 0, since n minus n, because it is being said that n minus 1 is greater than 0. That's why, because n will not be equal to 0. Okay, so that's why it is actually n minus 1 is greater than 1. That's what it is actually saying. The n is greater than 0. Okay, so when you see the behavior when n tends to infinity, starting for n is equal to 3, so there is no point where the x that belongs to it is infinitely many an. Okay, so that's why the here also the limit when it is check that infinitely many times the an will occurrence of there. So that's why there is this also should be the 5. Okay, because the event which you are telling, that behavior when you are saying from at tends to infinity, when at tends to infinity, so that's why where it is saying that when here also you can say, let's take it here, 1 minus 1 tends to n tends to infinity, here it becomes 0. Okay, but the problem is that 0 is not occurrence of that. Okay, an is actually here n is actually greater than 0, not here the 0. Okay, so that's why the an which is belonging to that, they don't have any set which is actually belonging to the when it tends to infinity. Okay, so that's why it is infinite. Let's move forward, try to solve this problem. Okay, let me give the solution for this. What it is saying that p an is equal to 1 by n. What is the value of probability of lim sub, that is an. Okay, when you see that कि suppose we are asked that कि this is the omega, means infinitely many n. When you series check, when you do, when you take summation of n is equal to 1 to infinity probability of an actually simply is 1 by n. Okay, so probability of n is equal to 1 to infinity divided by 1 by n. When you sum it up, 1 plus 1 by 2 plus 1 by 3 plus dot 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 1 by infinite. Okay, so it when you say that ki it actually diverging. Okay, why? Because when you say this is 1, this is zero point 0.5, that is 0.33 plus something something 0.25, then all values are a plus 0. But when you sum it up, this is also infinitely many terms are there. Here 1.5, here when you add this 1.83, when you add it up it is more than 2. So that's why when you are having the infinitely many times, so it is actually kind of harmonic series which is actually expanding. So that's why this actually the series actually diverges. Okay, when you apply this Borel-Cantelli lemma, so here when you having the probability of an which is less than infinity, so then it will be 0. But if you are having the probability of an that is summation is equal to infinite, then the conclusion depends upon the independence. Okay, if the events are independent, then that probability will be 1. If events are arbitrary, no dependence assumed, so here the only guaranteed term is not the second. Okay, so that's why interpretation here is that ki only have it is being said that the probability of an is 1 by n, so that's why that doesn't assume that ki it's an independence. Okay, so that's why it is 0. But if it is both the events are actually independent, the probability it is being said that ki an occurrence of the one event of the an is actually dependent upon the seconds, or it is independent, it is not being clearly said. So if you see the problem also here also, it is not being clearly said. So that's why you should not assume that ki probability means ki it's actually independent. So that's why the correct option is actually 0. Okay, so let's move forward, try to solve this problem. Here if you see here, it is being said. Okay, try to solve this. Okay, let me give the solution for this. So when you say that that is similar fashion, when you starting summation of n is equal to 1 to infinity, the summation in infinite. Okay, but it is also being that key events are independent. So that's why this limit will be 1. Probability of occurrence limit will be 1. And intuitively you can say that that event has constant positive probability of zero point 0.5. So when you having the trials that are independent and infinitely many times, so it will surely occur that event only. So that's why that probability will be 1. Okay, so the correct answer will be the. Let's move forward and try to solve this. Here in this problem it is saying that in between the 0 to 1, when you have this an is equal to in the open interval, that is o 0 1 by n, and bn is equal to 1 minus 1 by n comma 1, then what is the value of limit, that is an union bn? Okay, try to solve this. Limit here such that k n tends to infinity, take it like that. Okay, let me give the solution for this problem. It is saying that when you're having the an union bn, so here an behavior is such that it is 0 to 1 by n. For any fixed s greater than 0, eventually 1 by n will be the less than x, and x does not belong to 0 to 1 by n. So because the here for long of n, So only x is equal to 0 could potentially remain, but 0 is excluded from the cell, so an is actually 5. So here also you can say that the union is actually when you're considering the both terms. Okay, so bn is 1 minus 1 by n. So for fixing the x is less than 1, so choose that ki 1 will be equal to 1 upon 1 by x. Okay, so here also like that. Okay, so then 1 minus 1 by 1 n it should be greater than x, so x does not belong to this, so that's why the bn also here actually limit is 5. Okay, so both the events are 5 when you having, so limit sup that is an union bn, that is m5 is equal to 0. Okay, so that's why correct answer is 0. Let's move forward. So here is the independence and conditional probability based problems are there. So the first problem is such that ki, x and y are independent events, and you means ki, it is belonging between the 0 to 1, that you already know. That is, and the, when you have to compute that ki, what is the probability when x plus y is less than half. Okay, try to solve this. Okay, let me give the solution for this problem. It is being said that ki, when you ask that ki, here it is asked the probability that the sum of the two event which is informally in between 0 to 1, should be less than 1. It means that x plus y is less than 1. That was the probability is being asked. Okay. If x and y are independently uniform, their joint density is such that xy is 0 to 1 and cross 0 to 1. It means that when you're having x that is 0 to 1 and y is 0 to 1. Okay. So getting the probability which is less than half, okay, and xy is belonging to 0 to 1. These points are also being considered. Okay. Okay. So when you see that key, what could be the probability of that? It means that when you see like this, okay, when you're having because the probability sum should be always half. Okay. So when you see that, let me erase it. Okay, it is not half. Here it is half. This is the zero point 0.5 half on the y-axis. This is the half on the x-axis. So that's why this is actually the probability. Okay, getting my point. So this is the zero point 0.5 and this is the zero point 0.5. What is being probability? Let's see that. So probability of getting x plus y less than half is equal to this area, triangular area, that is half multiplied by zero point 0.5 multiplied by zero point 0.5, and the total area. Total area is the rectangle. Rectangle is 1 cross 1. So what is the value of the probability? It will come out to be 1 by 8. Okay. 8 means point 81, it was 16, 8 5 40, 0.125. So the correct option is here is 1 by 8. Okay, getting my point. So space is overall, that is rectangular space in between the 0 to 1 x and 0 to 1 y. But when you're getting the x plus 1 or x plus y which is less than half, so you have to consider that triangle. When x is being zero point 0.5, the y is 0, and when the y is zero point 0.5, x is 0. Okay. So that area will be the overall probability, and the total area is the area of the rectangle. Okay. Let's move forward. If it is being asked that the probability of x plus y is less than 1, x plus y, then you have to consider this triangle. So it will be such that, okay, 0 to 1, this is also 1. So this will be the probability. So here will be, what will the probability? Half multiplied by area, that is 1 minus y 1. Area of rectangle, that is 1 by 1, that is 1 by 2. Okay, 1 by 2. Okay, half multiplied by 1 by area will be equal side 1, x plus y less than 1. Okay, area will be half this half divided by 2, scaling down to threshold, that is how. Okay, so the correct answer is half in this case. Okay, let's move forward, try to solve this. Okay, let me give the solution. What is being asked that your argument is such that x and y are IID. That is, the event is x is less than y and y is less than work are equally likely events. Okay. So if they are disjoint set, then the all outcome except the measure zero, that is case x is equal to y. Okay. So it is being said that ki x less than y, our probability of y less than x is equal to half. Direct calculation to confirm means कि when you find the probability density, that is probability of y greater than x fx of x ds. Okay, 0 to infinity. Okay, but here it is says that fx of x is equal to exponential of e to the power minus x. Okay, put the value when you put it here. So probability of y greater than x is also e to the power minus x. Multiply it, you e to the power minus 2x, you will get the half as a correct answer. Okay, here you can say that, see that what is being said, that exponential of 1, and here x is less than y, so that's why here it is e power minus x. When you get the probability is half. Okay, correct answer is option A. Okay, try to solve this problem. Here it is says that ki two dice is being rolled. Okay, and A is actually the sum is even, and B is the first die is even. Okay, and it is being asked that ki let me know whether A and B is actually independent or not. Okay, try to solve this. Okay, let me give the solution for this. Here, the question is actually quite different. Here, it is not directly being asked that events are independent, find the probability. Here, it being asked that A is sum is the even and B is the first die is even. Okay, so consider that whether you have to tell me that whether independent or independent A and B are there. Okay, so what is the how to check that if the events are independent, then the probability of A intersection B will be the probability of A multiplied by probability of B. Let's say what is the probability of occurrence of A? That is the sum is even. Okay. So total outcomes sum is even, that is 36. If sum is even, it means the both dice are same parity. Parity means either even or odd. Okay. So that's why out of 36, 18 will be such the event when the parity will be the same. That is even or odd. Okay. So that's why the probability of occurrence of A is actually 18 by 36, that is half, that is equal to zero point 0.5. And what is the B event? B event is such that first die is even. First die is even when you see that is 2, 4, 6. It means out of all the 6 events, that is 1, 2, 3, 4, 5, 6, first die is even, that is 2, 4, 6 will be the 3 by 6, that is equal to zero point 0.5. Now the important point is the how to compute the A intersection B. It means that first die will be also even and the sum will be also even. Okay. So that there are first die even, that is three options are there. Okay. So for some even, that is second die must be even, that is three options, that is favorable outcome will be the 3 multiplied 3, that is 9. Okay. Out of 36 even, the favorable outcome is actually 9. So what is the probability? That is 1 by 4, that is equal to 0.25. Okay. So here if you see the probability of A multiplied by probability B is equal to 1 by 4. Also probability of A intersection B is also 1 by 4. That's why probability of A intersection B is equal to probability A multiplied by probability of B. That it means that A and B are actually independent. That is S. Okay. Let's try to solve this problem. Here it is being said that probability of A is equal to zero point 0.6 and probability of B is equal to zero point 0.5. You have to compute that probability of A intersection B such that A union B is being already occurred, or you can say that probability of A intersection B intersection of A union B divided by probability of A union B. Okay, try to solve this. Okay, let me give the solution for this. When you say that it is being probability of A intersection B, you need the conditional probability that A intersection B such that K union B, probability of A intersection B, that is probability of A intersection B, probability of A, probability of B. A union B such that probability of A, probability of B minus probability of A intersection B, that is simply equal to zero point 0.3, that is zero point 0.8. When you divide it, it will become zero point 0.3 divided by zero point 0.8, that is 3 by 8, that is equal to 0.375. Okay, so the correct answer is 0.375, 0.3. Okay, but it is nearly equal to zero point 0.4. Okay, so the correct option will be zero point 0.4. Okay, let's move forward. Try to solve this problem. Okay, let me read the problem. It is saying an urn has a 5 red and 5 blue balls. Okay, two drawn without replacement means two balls is being drawn and without replacement. It event A is such that first is red, event B is second is blue. Okay, R, A and B are independent. Event A is that first is red and say event B says that second is blue. Okay, kind of two balls is being drawn. Okay, this is A event and this is B event. That is first occurrence is red and it can be either. So two options will be there, RB or RR, and here also the two options will be there, RB or BB. Okay, so it is asking that whether the two events are independent or not. Let's check it. Okay, probability of A, when you get this all the possible events, okay, 5 5, it means that ki 10 events will be the possible. So the 5 event will be such that keep you will get the probability that first is actually r, okay. So it will be a point 0.5. When you see the second option, here also the when you say the second ball is blue, that is also the 5 option, that is 5 by 10, that is point 0.5. What about the option, this probability of a intersection means first will be the red also, and the second will be such that it will be blue. Let move forward. What is saying that first is red, second is blue, okay. And first is red, the probability is that 5 by 10. Given that the first is red, we have 9 balls being left because it was without replacement. So what will be the total probability? That is 5 by 9. When you multiply it, that is 5 by 10, then you pick it up, that is 5 by 9. So it will total become 25 by 90, that is 0.2778, okay. When you multiply probability of A and probability of B, it is simply 0.25, though both are not matching, so that is why it is not independent, okay. So it will be actually dependent events are there. So try to solve this. This is CDF probability and distribution law based problems. Try to solve this problem. Okay, let me give the solution for this. When you see the fx function, what is being telling that when you draw it, fx is actually 0 when you consider x less than 0. Let me take another pen. X less than 0, when it is x less than 0, and when in between the 0 to 1, it is x square, basically like this, okay. This is x square. When at 1 also greater than 1, fx is actually equal to 1, okay. So it is being asked that when you see the options, is this a valid CDF? So to check that whether it is valid SDF or not, so you have to check the continuity. Continuity means when you see that x less than 0 at what point, okay. So at the discontinuous points, that is 0 to 1, okay. Less than 0, you are having 0. When you greater than 0 limit you take, that is also 0, because x square, when you keep the 0, that is actually 0. Okay, it is matching. When you see the less than 1 or 1 less than 1 tending to the left hand side, put the x square value 1, you will get 1. Here also 1. Okay, so both are limit is actually matching, that at the discontinuous point when you take the at 0 also at the 1. So that's why this. And also the what is the value of the x tends to minus infinity? When you take the minus infinity, it is 0, and when you take the x tends to plus infinity, it is 1. So that's why the all the CDF conditions are applied, so fx is a valid CDF. Okay, that's true. Let's move forward, try to solve this problem. Okay, let me give the solution for this. It is being asked that we are having a CDF which is in form 0 to 1, and definition of that you get in 0 to 1. It means that x less than 0 you are having the 0, in between the x is equal to 0 to 1, that is x, as greater than 1, that is 1. So evaluating from that perspective, it is zero point 0.7. Zero point 0.7 is lying in between this, so that's why this f of zero point 0.7 will be equal to zero point 0.7. Okay, let's move forward. Try to solve this problem. Okay, let me give the solution for the. What is asking that a random variable having the distribution with PMF Px is equal to k, that is p 1 minus p to the power k is greater than or equal to 0. You have to find out what is the f2. Okay, f2 means ki x less than or equal to 2. It means that x equal to 0, x equal to 1, x equal to 2, because they will been consider that k is greater than or equal to 0, and also here this PMF. Okay, so when you keep the x is equal to 0 and compute it, it will become p. When you keep the x is equal to 1, that is p1 minus p x is equal to 2, that is p1 minus p of square. When you sum it up, f of 2 is equal to p1 minus p plus p1 minus p square. And sum it up, what you will get, simply the geometric mean, that is 1 plus p 1 minus p, that is simply equal to 1 minus 1 minus p of cube by p. Okay, f2 f2 is multiplied by p, you will get 1 minus 1 minus p power cube. Okay, p, that is equal to 1 minus 1 minus p of q. Okay, so correct option is option A. Okay, try to solve this problem. Okay, let me give the solution. Let's read it out first. What is saying that a mixed distribution has a continuous part with the density is equal to lambda e to the power minus lambda x. Okay, such that x is greater than 0. And atom at 0 with mass zero point 0.2. Then the what is the value of f0? So f0 is such that the probability is x is less than or equal to 0. So when you consider the contribution from the continuous part, so the density is actually defined lambda e to the power minus lambda, supported that x is less than 0, and this probability will be or 0 or greater than 0. Okay, so x is equal to 0, by definition it is saying that mass is actually zero point 0.2. Okay, so considering p is x is equal to 0 is equal to zero point 0.2, f0 is zero point 0.2. Okay, so that's why the probability is saying that f0 is actually equal to zero point 0.2. Okay, let's move forward, try to solve this problem. Here it is saying that ki if x has a CDF, fx is equal to 1 minus half to the power x, x is equal to 1 2 dot dot dot, and then the what is the probability of x greater than or equal to 3. Try to solve this. Okay, let me give the solution for this. It is being asked that ki when you're having the CDF, which is defined as fx is equal to 1 minus 1 to the power x. So what is the value of probability of x greater than or equal to 3? Or you can say that 1 minus p x less than or equal to 2. That is also being correct. So for computing the probability of x is less than or equal to 2 using the CDF, that is equal to f of 2 basically 1 minus half to the square, because it is also the being said a half to the power x. So x is here simply 2. So that's why 1 minus half of square, that is 1 minus 1 by 4, that is equal to 3 by 4. Okay. When you compute x greater equal to 3, that is simply equal to 1 minus 3 by 4. Okay. That is 1 by 4. Oh, okay. Matching with the option, that is half 1 by 4, that is 1 by 4, that is half of a square. So the correct option will be the option A. Okay. So I have kept a lot of problems based upon this kind of concept. So about 30-35 problems are there. 20 we have covered in this session, but 20 means 15 is remaining for this session. So try to solve them, and if you face any means problem in solving that problems, we will discuss that in the next tutorial session. Okay, that's all for the today's tutorial session. Thank you so much.